I had a student that had concerns about question number 5 from the week 4 assignment. I'm not going to work out this problem, but I am going to give some hints about how to approach each part of this problem. So for part A, well, first off, looking before we even get to part A, we're given some information about the problem. We're given that the mean is 55 inches and the standard deviation is 6 inches. So mean is 55 and standard deviation is 6. Alright, so we'll be using that information on all these parts. So part A, we'll address that right here. What is the probability that a randomly chosen 10-year-old is shorter than 48 inches? So the 10-year-old is just part of the variable, because as mentioned here, this is the height of 10-year-olds. So randomly chosen 10-year-old, so 10 is not really a number that's dealt with in this problem. It's the shorter than 48 inches. So we need to figure out, and also another important information, it's normal. So we have a normal distribution. So we're going to be using the, as you may imagine, the normal CDF and maybe possibly the inverse norm at some point. So both of those can be found under second vars, where vars, if you hit second vars, that'll take you to the distributions, and you should be able to find normal CDF and inverse norm. Normal CDF will allow you to go from values in between two values, less than or greater than some value from a normal distribution, and find a probability. So if it's asking about probability, if the question is about probability, then we're going to be using normal CDF. If it's asking for a value given some sort of probability, so we're going the opposite direction, going from probability to value, then we'll be using inverse norm. Inverse meaning backwards, assuming, like compared to the normal CDF. So here we have, what is the probability that a randomly chosen 10-year-old is shorter than 48 inches? So we will be using normal CDF because the question is asking, what is the probability? And we want to know shorter than 48 inches. So think about, keep in mind that the general formatting for normal CDF is the lower value in your interval, or lower bound, they also call that, and then comma, and then you'll enter in the upper bound, and then you'll enter in your mean and then your standard deviation. So there's a video showing how to use your TI graphing calculator and approach the normal distribution functions, mainly the normal CDF. So, and I've made videos on using the inverse norm already. But anyways, you may want to take a look at that video. So I'll just tell you for part A, that if it's shorter than 48 inches, that's less than or equal to 48 inches. So the lower bound, there is no lower bound. So just enter in some really small number. So -1,000 will be fine for lower bound. Upper bound, so there's a highest value. So it's shorter than 48 inches, so the upper value is 48. So less than or equal to 48. So that'll be 48, and it goes down for a long distance, forever, really. The mean is 55, and standard deviation 6. So you'll enter that in and get a solution. Now for part B, we are asked to find the probability, and we have 60 to 65, between 60 and 65. So I think it's really easy to use a normal CDF to find when you're dealing between two values. So lower bound, upper bound, mean, standard deviation. So we're going to be using normal CDF again. And then part C, if the tallest 10% of the class is considered very tall, what is the height of the cutoff? So we want to know if the tallest 10%, that would mean the 90th percentile. The formatting, I'll just write it here. Or that part I wrote there. So this would be inverse norm. Since we're going from a percentile to a value, because we want to know what is the height. So we're going from percentile to value. So that's inverse norm. And what you have is the percentile. And then the mean and standard deviation. Percentile here meaning less than or equal to some value. So tallest 10%, that means 90% is below. So that would be in decimal form 0.9, and then you'll have your mean and standard deviation right here, comma mean. So 55 and 6. Okay, so that's C. That's how you approach it. And part D, what are they asking here? The height of a requirement for Batman the ride at blah, blah, blah is 54 inches. What proportion of 10-year-olds cannot go on the ride? So this is just interpreting the problem. What proportion of 10-year-olds cannot go on the ride? So we're dealing with the less than or equal to. Very similar to part A. So part D is very similar to part A, but we just have a different upper bound value. So hopefully this makes sense. Let me know if you have any further concerns, and I'll be more than happy to help.